All right, hello everybody. My name is Charles Nebeze. Welcome to this presentation. I'm the Vice President of Business Development and Commercialization with the Center for Excellence in Mining Innovation and also with the MICA network. Today we're going to be joined by Jason Lycum, who is going to be presenting to us on the non-cyanide gold recovery by Environmental Technologies. And Environmental is one of the technology companies that is being funded by MICA. But before we jump into Jason's presentation, I'd like to let you know that we've actually done 14 other webinars of these approved projects, and this is webinar number 15, and we've got one more to go, which we'll be adding to the list later on today. You'll see from this list here that there are 16 projects that we have supported, and obviously Environmental is one of them. I also want to let everybody know that you are invited to submit into the second corporate proposal that's open right now. So you can actually submit for the second intake. I think we've got a little bit under $18 million that will be made available for the second call. And you can just use your phone, click on this QR code, and you'll be able to get to those links. Now, it gives me great pleasure to welcome Jason again. Jason, to this presentation on non-cyanide gold recovery with Environmental Technologies, Inc. Jason, the floor is all yours. Please go ahead.
Thank you, Charles, for the introduction. And thank you, obviously, for the support of the CEMI team and the MICA network to support our project to commercialize what we feel to be an important technology innovation. My name is Jason Lycum. I'm VP of Business Development for Environmental Technologies. And we are a publicly traded company, so I'm going to be making some forward-looking statements in this presentation. And therefore, I'm obliged to share this disclosure with you. That's the fine points. So Environmental, who are we? Well, we, again, are a gold recovery technology company. We operate according to two primary premises. Firstly, that miners want to seek to improve performance. Number one, by cost reductions associated with their operations. And secondly, they also want to enhance their social license. Very important now more than ever, and we all can agree with that point. So our objective is to use our technology to help gold miners achieve those two key objectives. Ultimately, we do want to change the way the world mines gold or recovers gold from mining operations. And we feel that we can help those miners to unlock the full value of their operating assets. So how can we achieve that? We can achieve that by those two objectives by using our non-cyanide and reusable lixiviant technology to enhance the value of those assets, but also reduce the environmental footprint. How can we do that? Well, our process operates at a neutral pH and is flexible within a certain pH zone. It operates at ambient environments, so that's pressure and temperature. And importantly, our process produces no wastewater. We've developed our technology over the course of 5 years through initial laboratory R&D and through pilot programs. And in the course of that 5-year development stage, we've been issued 2 patents, and we've also built a number of trade secrets around those patents to further obfuscate those or further protect our IP suite. Although the IP suite is very novel and proprietary, the way we deploy that is primarily through readily available equipments. So while there's a few proprietary pieces of equipment or components, it's very simple to assemble and with those readily available, like tanks, stainless steel tanks, plastic tanks, hoses, pumps, and so on and so forth, automation controls, these things are readily available. And it allows the miner to incorporate that into their existing process infrastructure at the mine site. We are commercial ready now. And so we feel that the MICA funded project of this recovery plant demonstration circuit will not only deliver continued operational data, but produce improved revenues for our mining partner. The question is, why would mining partners want to consider Environmental? Again, the answer is simple, because if they spend the time to investigate, they'll know or they'll learn that we can help them improve their revenues on site. We enable our mining partners to gain greater control because of additional on-site gold recovery. And that's certainly important versus the shipment of concentrate processing downstream, usually offshore to smelters, incurring costs, treatment charges, sometimes penalties, and certainly shipping costs and the associated emissions related to those endeavors. Furthermore, our scalable solution enables gold miners to develop deposits where cyanide might be banned, or cyanide is opposed by local stakeholders and communities, or requires very lengthy permitting process timelines. So we can deliver efficiencies in those situations as well. Our process reuses its lixiviant indefinitely. It operates again in a closed loop environment, and then, of course, again, as I mentioned, produces no wastewater. And this wastewater issue, of course, is of particular importance in arid regions in many areas, whether that's Nevada, for instance, even California, throughout South America, where gold mining operations are located in areas where there's restricted water use or just a lack of available water. So these operating parameters serve to reduce the maintenance, the monitoring, the remediation costs, but also reduce environmental footprint for those gold mining operations. Here's a very simple process flow sheet, and it demonstrates that it's not a highly complex process, but it is closed loop. And that allows the lixiviant to continue to be recaptured, regenerated, and reused time and time again. In addition to that, because the rinse water is processed to recover residual lixiviant reagents, we don't spill any wastewater. We don't produce wastewater. So again, it's operates within primarily readily available tanks, pumps, and controls. So this again identifies that it is a fairly simple process. At the end of our process, we recover the gold effectively from electrowinning, ion exchange, or a combination thereof. Well, how do we compare to, I've got a freeze here. How do we compare to the incumbents in the industry? How do we stack up against cyanide is a really key question that many of the mining companies that approached us ask, one of the very first questions. Here's one example of how we compare. In most cases, we demonstrate superior leach kinetics with then cyanide. And in many cases, our recoveries are as high or very comparable, in fact, sometimes superior to that of cyanide. In each use case, though, we test the concentrate material to optimize our process for that specific material. We acknowledge that no two mines are really the same when it comes to mineral processing. There could be mineralogy issues associated with even how they affect our lixiviant. So we go through testing in consideration of pH balancing, pulp density, residence time, reagent concentration, and recovery calculations. And while we share with you this slide that shows very short residence times and fast recovery rates, most often what we do is we leach materials in similar timelines to the cyanide test to draw a very inline comparison. This is a picture of our rudimentary looking pilot plant located in Metro Vancouver. This plant processes, or the circuit processes, about 100 kilos per cycle, which is sufficient for executing off-site pilot programs. And we've done a number of pilot programs over the course of our life cycle thus far. They've all been used, each pilot program has used the same lixiviant, which is again is recovered, regenerated after each leach cycle, and then reused for the subsequent leach cycle. The tails are rinsed. You see the small filter press there. So we rinse those tails to extract any of that entrained lixiviant and any attached gold associated with that lixiviant. Ultimately, very minimal amounts of reagent are lost to tails, and those small amounts of reagent are associated with the moisture content in the tails. Thus far, our programs, either on-site or off-site, have recovered almost 2,000 ounces of gold, about 1,950 ounces of gold. So in the first pilot program that we did, it was an off-site program. This was done, completed on the mine site or the project site in the Yukon. You'll note here that the recoveries were very positive, averaging about 94%. And that's especially notable considering that we did not complete any process optimization for the specific concentrate material. This was a gravity concentrate. You'll note here too that the gravity concentrate contained very high values of arsenic, which rendered this specific material unsellable to smelters. So while this is preliminary data, it still demonstrates very strong validation that the environmental process can be adapted for use cases where there are high levels of deleterious metals, such as arsenic or antimony. These things negatively impact the marketability of concentrates, and yet we can recover the gold on site for the mining partners. The second area after gravity concentrates, which are our key focus of application, are in flotation concentrates. This study once again shows the high recovery rates and the short leach residence time for this specific material. How is this important for miners? Again, if a miner needs to ship that, if they can't get a cyanide permit or do not want to pursue a cyanide permit, they are absolutely required to ship the concentrate off-site. We can help them with those recoveries on-site in a rapid period of time. And once again, we've demonstrated that the recovery rates and rapid leach responses are very comparable, or in this case, superior to that of cyanide. So for companies, miners looking for an alternative to cyanidation after concentration, we should be able to provide positive results for you. And that's really important because we realize from our dialogue with several mining companies that they are interested in building social license. They've actually approached us because they want to avoid cyanide on very specific mining sites. So operators need to be balancing social license, environmental footprint with price performance. And that's where we have a solution. The third area where we can provide value is in the recovery of gold from pre-treated refractory concentrates. We've achieved high recovery rates and very short residence times, as you'll note by the green columns highlighted. These tests demonstrate success on a broad variety of materials, various refractory concentrates, and using the pre-treatment processes such as Albion, owned by Glencore Technology, or autoclave or roasting discharge. We perform in each case very well. So one key advantage in this application is the ability for the environmental process to recover the gold without a major pH adjustment. In some cases, the concentrates are in the range of 3 to 5 pH, whereas they need to bump that pH level up towards 10 and 11. And they usually do that in order to affect cyanidation. And they do that through the addition primarily of lime. So in our test studies, although again, rather preliminary, our internal numbers suggest that our cost associated with treating and recovering the gold from refractory concentrate material, it can be less than the supply of lime and the costs associated with that. So these costs and process efficiencies are in addition to already those offered with general flotation concentrates. So our project is approved by MICA for a 1 ton per day gold recovery circuit, which will be installed in a mine soon to be finalized. We have recently completed our OPEX studies that validate our reagent recovery system, and which then therefore defines our most significant operating cost input, that loss of reagent to the tails. We expect to share this information with our mining clients within the next month or so. We've also already completed scoping level equipment lists and costs, and in early 2023, we'll engage consultants to complete full design and engineering for the demonstration 1 ton per day circuit. And concurrent with that stage of development, we expect to undertake bulk sampling of our pilot, our client material at our Metro Vancouver pilot facility to optimize our process for that specific use case. Again, that includes pH analysis, pulp density, residence time, and reagent concentration. And these will be very key inputs for the final consideration on the construction of the demonstration plant. Thereafter, just to digress a little bit, we go to construction. We believe the procurement associated with that construction and the construction and shipping to site will take between 6 and 9 months. And thereafter, it will be ramping up operations, testing, and then getting into full operations. So in summary, the operation of the demonstration gold recovery circuit approved by MICA will generate commercial revenues for the miner. Therefore, we can say we are commercial ready. This project will also demonstrate the mine site economics and efficiencies that will serve as a showcase for gold miners who consider themselves fast followers in seeking new innovations. Presuming project success, we will seek additional opportunities for gravity concentrates, but look to expand the scope of our operations with flotation concentrates here in Canada and abroad. Lastly, our IP is sound, it's protected. Our technology is scalable, stable, has favorable operating parameters, and these things allow miners to reduce their environmental costs or footprints and reduce their operating costs, all of which deliver value for the miners and their shareholders. So what's our ask? For those of you who are in the audience listening, I thank you for your kind attention. We're looking for additional partnerships. If you're a gold mining company looking for innovation to improve your economics on site, please approach us. We're very confident we can demonstrate positive numbers for you. We are also a startup, like most of the other MICA funded programs. So we are looking for funding, and coincidentally, we have a private placement open right now to fund our operating costs throughout 2023. So if you're interested in discussing that opportunity with us, please contact us. And if you're not a miner, and if you're not an investor, but you're interested in collaboration, please approach us, because we believe that innovations ultimately have to be collaboratively based. Multiple innovations will provide a better platform for the mining sector in general. So we're looking forward to talking with anyone that might be interested. So thank you very much for your time. Again, if you're a mining company, let's demonstrate for you how we can help you reduce cost and environmental footprint. And thank you very much. I'll turn the presentation over back to Charles.
Awesome. Thank you so much for the presentation. You know, as I've been saying to other presenters, every time we sort of hear you guys tell us about your technology and where you're going with it, we just get more clarity on exactly what the value proposition is. So we do have a couple of questions for you. And I want to start off by maybe asking a question about your project milestones. So you did show there were sort of 4 stages, right? Where you started the costing and at the very end with the implementation. There's 4. Could you give us some idea on what the timelines are in terms of dates? Is it how many years away are you to implementation? Maybe give us an idea on that.
Sure. Yeah, good question. Our timeline, our project effectively is a 2.5-year length of time. So the first stages of OPEX and CAPEX calculations, we've already begun. So we'll have the opportunity to share that with our mining clients and partners, potential partners in the very near future, pardon me. And subsequent to that, early in 2023, we expect to receive the bulk sample. It'll take us about 12 to 16 weeks to process that, generate the data, and we'll plug that into our model. Thereafter, we'll look to start procurement for our construction materials in late Q2, early Q3. We believe that whole process of construction, procurement, and shipping on site will take between 6 and 9 months. And thereafter, in early 2024, start the ramp up of that operation. So that hopefully gives you the first year is set up, and then by shortly after the full year, the end of the first full year will be operational.
Gotcha. Thank you for that.
I have a question. Thanks for that, Jason. Very interesting. You said there's no wastewater. How much water is used in this process?
Very little. I mean, we do have our wastewater, our processed water held in tanks. The loss of that water is associated with moisture in tails. Even with water vapor in our process, we capture that water vapor because it also contains even grams of our lixiviant reagent ingredients or components. We want to recover as much of that as possible. So the lack of wastewater is actually a positive byproduct of the necessity to recycle, regenerate our lixiviant. So in the case of actual wastewater, whether that's evaporation or entrainment in tails, we consider that to be about 20 liters of water produced or within those tails per 1 ton of material processed. And in the case of gravity concentrate processing, the tails are reintroduced into the circuit. So any moisture is actually helps to balance out the water use draw throughout the rest of the circuit. And if we think of gravity concentration, it's a wet system. So we actually dry the table tails prior to going into our circuit, and then they get reintroduced. So we try to capture water at every stage of this of our portion of the operation. Very minimal loss of water to tails.
That's cool. That's really cool. What about the tailings? How are they disposed of? Is there a need for special tailings treatment?
Well, once again, in the case of gravity concentrate processing, we reintroduce the tails back into the circuit. There is, if we consider a concentrate, a table tail to be, in one case, 500 grams per ton, so a very low volume but high grade material stream. Even if we achieve 95% recovery, there is still, let's say, close to an ounce of gold left in those tails. So they're reintroduced into the circuit and circulate. Eventually, if the operation has a flotation circuit, they will ultimately report to the flotation circuit. So the tails are then sort of out of our hands and then are reporting to the float concentrate, which is thereafter either shipped to a smelter or processed through other means. So in our portion of it, we don't really have to deal with tails. In the case in the future where we need to, we advance to the processing of float concentrates, these tails will have low moisture content as well, so they're suitable for dry stacking. And yet, while there is a very small amount of reagent component in those tails, it will be below detection levels. And in fact, that key ingredient in our reagents is in fact suitable for human consumption. So it's not a highly caustic, certainly below detection levels, we can't even find it. So that's one key consideration of how the operator can deal with tails.
Thanks
Awesome.
for that explanation, Jason. Appreciate it.
Yeah, so I have another question for you, Jason. And you mentioned sort of the fact that you don't. This is an alternative to cyanide. What about those people who are using mercury to do their gold extraction? Can you comment on how you would address that?
Well, typically what we see as far as industrial scale mining operations, certainly for Canadian miners, the use of mercury is a no-go zone. It certainly is still used in artisanal mining. However, that's not really our focus of application at this point in time. So that's something we're kind of not wanting to approach. One of the key factors associated with that is after for instance, an artisanal miner uses mercury, the tails are highly contaminated. So that might be a downstream application for us or a down the road application. But it's not representative of our first three key applications. That's again being gravity concentrate, materials, flotation concentrate, and then the refractory concentrates as well. So these represent a really large percentage of the global gold produced on an annual basis. It's about 30% in total. A lot of that is still using cyanide more specifically, and that's the two or the three areas of the market that we aim to penetrate.
Gotcha. Okay, the question I have is your reagents that you're using, is there any need for government regulations, standardizations that you need to adhere to?
No, it's safe to transport. There's no key hazardous waste handling requirements versus cyanide, which in some cases, unfortunately, or even now, is more difficult, more costly to get a hold of. But the transport, it can be a key consideration. We don't have those considerations with our reagent components. Once again, our published patent shows some of the key components of that, and then once again they're fit for human consumption. So when we think of iodine used in water treatment, obviously iodide used in table salt. So these things are actually rather benign, and in the concentrations that we use them, they are benign. So it doesn't require stringent material handling is always very important for environment and health and safety. We don't discount that whatsoever, but in comparison to very strong acids and cyanide as well, we have a bit of an advantage in that regard.
Gotcha. Just maybe my last question is, the mining industry has been, maybe unfairly characterized as being very slow to adopt technologies. But I think one of the things that we do know is that the mining industry demands to be able to see something in action. Show me exactly what you're talking about. Is there an opportunity for people to visit a plant that you have somewhere, a demonstration unit, so you can actually show them it in process?
Yeah, absolutely. So our facility is located in Metro Vancouver. It's not always operating, of course. These are regularly scheduled pilot projects. But at any time we can schedule a visit. It's a very simple looking unit. So I think it really alleviates the concern on that whole black box approach. It's really easily implemented on site. So we encourage people to come and visit us, yes.
Awesome, thank you for that. Oh, Lanissa, any parting questions?
No.
Awesome. Okay, Jason, thank you so much for the presentation. Jason, one of the things we've been doing is giving the presenters an opportunity to say some parting words to the industry for this presentation that you just did to us. So can you just maybe give us a couple of words or tell the industry some parting words on what you are looking to get from them, just to remind them of some of the things you've said in the presentation. Maybe take a minute or so to do that.
Sure. We do acknowledge that the mining sector, the mining industry at large is focused on innovation. They've been messaging their achievements in corporate social responsibility, in environmental stewardship, in innovations as well, electrification, digitization, all these things. So we're very pleased with the level of advancement in the last 5 years that the industry has gone. And more particular to gold mining, we see the engagement, incoming questions from miners with regard to how can they continue to reduce environmental footprint. I just would like to invite any gold producer to investigate, and so that we can prove to them how we can implement. And we do appreciate that many are fast followers. I've heard it say that they want to be first to be second. So we appreciate that they want to see a demonstration. We're happy to demonstrate that, how we can help them achieve those objectives, as I mentioned first. Reduction of cost and reduction of environmental footprint. We're very confident we can perform. So again, our doors are open, our phones are free, so please just drop us a line and let's talk about how we can help you to improve your operations.
Thank you very much, Jason. And folks who are watching, there you have it. The future of gold mining is clean, green, and these are the kinds of technologies that are going to make it happen and allow us to all meet those targets that the world is setting for a greener planet. Thank you very much, Jason. Appreciate you.
Thank you.